we decided that we wanted to have a conversation about data centres and AI because, as you've heard earlier today, probably every second meeting I go to these days, somebody asks me a question and I can't answer it. And I don't think anybody in the room can answer it, but somebody tries. And I just think it's a domain that's a good one for ECA to sort of open up and to create sort of an informed conversation, recognising that, as you mentioned, Lewis, there are not a lot of answers, but there's a lot of really good questions. It's an industry that Australia, all the jurisdictions in Australia are staring into very closely, and it's an exciting prospect for Australia, as you mentioned, as a potential source of future singularity in the international markets. And so I'm delighted that we've got three experts joining us here today. Just in the interest of time, I probably will avoid going through people's bios other than to say, Belinda has had 20 plus years in and around this domain with a number of marquee firms that you'd know very well. Lewis's bio you heard before, and Dr. Tim Jarratt, we're doing all the doctors today. Tim is the Group Executive for External Affairs and Strategy at Ausgrid, keeping the lights on today, and joins us from, I think, National Grid before that, one of the largest listed network firms in the world. So we've got some great expertise up here, and we're going to be asking you to enter any questions you've got into the app that Craig pointed you to earlier. I've got a few questions that will maybe kick off the conversation, but please make sure that you let us know the kinds of areas that you'd want us to focus on. So in the first instance, and perhaps Tim, I can reach out to you and ask you this question. And we heard from Lewis's presentation that a lot of the future prospecting, even the fortune telling of what data centres are going to look like in Australia, suggests that the capacity that they will occupy in the Australian market will go from sort of 2%-ish, slightly under 2%, of energy consumption up to maybe 10% in the next 10 years, maybe something in the order of 30, 35 terawatts we heard, with the potential, of course, for some increase in consumer bills, depending how that works, because there's different models, different ways of achieving this, and different jurisdictions in Australia have approached this, across the world have approached this differently. We've noted, of course, that the AER, in recent discussions and decisions, has been quite clear in suggesting that data centres have a role in contributing to the grid and so on. I'm interested, your distribution network is staring into these questions at the moment. I think Macquarie Park is one area where you're looking at. What are the considerations that you have in your mind when you engage with data centres and what it might mean for your consumer base?
Thank you very much. This is on, yes, great. I think I'll start by just saying how dynamic the situation is here. So if we look back over the last 2 years, so at the start of 2024, we had a pipeline of about 1 gigawatt of data center applications. So that ranged all the way through the pipeline. Today, that sits at 10.5 gigawatts. So that's in 2 years, we've seen it go from 1 to over 10 gigawatts. Now, some of that increase is due to people who were already in the queue, just growing what they were looking for. But also, we've had an awful lot more applications come through from new sites. So it's very, very unprecedented for a network like ours, which has had relatively stable growth. We've been able to kind of predict how we think growth will develop over the years quite easily. This is a very, very different proposition. And just put that into context, kind of the peak load on our network, so that's Sydney, Central Coast, Newcastle, Hunter, is about 5.3, 5.4 gigawatts. So that just kind of puts it into perspective of what's coming. Now, lots of that is very speculative. Lots of that are companies who are talking to us. They're talking to Essential, they're talking to Endeavour, they're talking down in Victoria. They are looking for connections. And so we are very much in the process of trying to work out what's real and what will eventuate. So with the other two networks in New South Wales, we published a report last year, back end of last year, called the Distribution System Plan. And actually we collectively looked at our different pipelines and tried to work out what we thought was a realistic number for New South Wales. And we're thinking that we're probably in the world of about 4 gigawatts overall being landed by 2040, something of that ilk. of which about 2 gigawatts will be in the Ausgrid area and 2 gigawatts will mostly be in Devers patch, but some will be in Essentials patch. So we've got a sort of a total of about over 20 gigawatts of applications between the three networks, and we think we'll get about 4 gigawatts into the state.
That's interesting, and maybe Belinda, I can ask you about that, because in the federated model, of course, different businesses are talking to different networks and different state governments and so on. Maybe it would be a good opportunity, Belinda, to help the audience here get a good sense of what is a data centre, and in the different forms, because we hear about these sort of hyperscale entities of 100 megs, utilising capacity equivalent to 100,000 homes. We don't know if they're the ones that are going to arrive here in Australia, or even the ones that are necessarily applying. Give us a bit of a sense of what your organisation is, because I think it's a new organisation, and also what you're seeing, what you sort of project your members will be interested to apply for.
Thanks, Brendan. So Data Centres Australia is we launched 3 months ago to be a peak body for the data centre sector, really to try and firstly educate people on what data centres are. This is such a rapidly changing environment. Data centres are not all the same. Louis talked about putting data centres in renewable energy zones. Well, there are some that would work for, but there's a whole lot that wouldn't work for, because they do different functions, they're different sizes, they serve different purposes and different workloads. So that's and they behave differently on the grid. So there's one-size-fits-all policies are part of the challenge here to really understand what we're talking about. For example, we have data centres that actually, rather than having flight controllers sit in towers at airports, now they sit inside data centres and control, flight paths, and they need the low latency, they need to be very close to urban facilities. So we just need to be careful about thinking there's some catch-all solution.
Yes.
What Tim's been talking about there is the biggest challenge I think we've had in this industry is around forecasting, and there's a whole lot of reasons for that. One, there's a bit of hype around the sector, and so there's lots of reports either put out by investment bankers, put out by property developers, because if you've got a piece of land and you suddenly can sell that with energy as a potential data centre site, you've just quadrupled or more your price on that piece of land. And since I started this role 3 months ago, I can tell you there's 2 or 3 people that contact me every day with a piece of land to sell me. So I don't actually build data centres, but that's happening. So the speculation and what's the pipeline look like, part of what we're going to do is put out some realistic forecasting data, because the pipeline is much smaller than what it looks on paper, and there's a couple of reasons for that. If a company that's looking to host its servers in a data centre, so a couple of basics, if for those that are not familiar, we used to have our compute sit on the desk. If you remember the hard drive that sat on your desk, we then took that and we networked and put them into the basements of office buildings, if you like, or a server room. And then we took them out of those server rooms and we've put them in purpose-built facilities, aggregated all that compute across the economy, put it in a purpose-built facility, which is 67% times more energy efficient to do that than run it in non-purpose-built office buildings. So there is an energy efficiency with data centres. We also don't count the energy use when it's in the distributed model across the buildings. That energy is seen on business bills, it's not seen collectively. I suspect if we did everyone's TVs went into a centralised system and you saw that energy use, in the US they did this calculation and it was significantly higher.
Yeah,
so there is an invisible load that already exists. We still have 80% of compute in this country in the distributed model, so on-prem we call it, in businesses. Just getting that into a data centre would be a 67% energy efficiency move.
Yeah, interesting. And I guess one of the questions that a lot of people have in their mind is this sort of virtuous circle that we saw in Luis's slides, which is, yes, there may be, depending on the number of inferences and the growth in agent-to-agent engagement and so on, there may be considerable increase in gross consumption, but there's also, I guess, a particular benefit that AI can bring to them, for instance, the management of a network in terms of utilization and maintenance and performance and so on. Is this something, Luis, I'm interested in your work, is this something that networks and the energy system more broadly are factoring into their considerations? Are we seeing networks sort of take up the mantle as sort of early adopters of AI in terms of their business models?
They should be. The way I categorize it or I explain it is, we gotta be data-driven businesses, right? If we operate a network, for example, we operate 9 distribution utilities, and I'm shameless to say we only have SCADA for one of them. So it is irresponsible now to operate an asset as important as a distribution business without data. And if I'm going to operate it with data, I need advanced data technology, which also means I need a good contract with a data infrastructure provider. In our own company, because we're this big conglomerate in the Philippines and basically the private sector does what the government can't, we're planning to buy a data center. And a portion of that data center is going to be dedicated compute for my grids. So that not only am I building the models that help me simulate market, simulate weather, because we get a lot of weather events in the Philippines, but also so that we can offload some of our inefficiencies by the use of that compute. Now, the data center will still sell to Google and we still sell to Oracle. We'll be thinking of a joint venture with Oracle. But we're giving a percentage of that contract, of that compute portfolio, directly dedicated to the obligation of helping our grid. And in that sense, we can, because we're the owners too, so they have to do what we tell them, we can tell them to bring renewables into it, which now becomes part of, we don't only sell energy, we sell data and energy as a data utility.
See, that's where it gets very interesting. And I noticed one of the questions that a number of people in the audience have put and boosted is that fundamentally this, how realistic is it that data centers will be able to bring their own green energy? What are we seeing at the moment? I'm interested maybe in Belinda and Tim's view on this. What are you seeing in terms of this sort of bring your own energy concept from data centers? Is this a big part of the conversation at the moment, or is there a chance that actually we will, growth in demand will make us fall back on fossil sources?
I think it's a nascent part of the conversation in terms of what we're seeing. Yeah. Certainly, if you're planning to build something in Sydney, you're just looking for a connection. If you're in Macquarie Park or something like that, you may be longer term thinking, trying to do a PPA somewhere further down the route. But I think actually, if we can move some of the building out into, say, around the Newcastle area, then you've got much more opportunity around that to get green energy in the sort of 100 Central Coast res and the kind of wider area. But it's not a big part of the conversation right now.
Yeah, so it's location dependent too, Belinda, yeah?
Well, I dispute that slightly. I think, and I'll plug, if you do want to know more about this, there's a couple of reports on the datacenters.org.au website. One of them talks about how data centers do contribute to energy infrastructure and how they offset energy through power purchase agreements. So at the moment, about 70% of energy use of data centers is done through power purchase agreements, adding 1.5 terawatt hours of new renewable energy to the grid. So, and that's not by legislative requirement, that's because data center operators and their customers have net zero by 2030 targets. Many of their loans, this is a huge capitally intense business, are sustainably linked, so there are financial incentives to ensure they're meeting their sustainability targets. It's not an industry that's dragged kicking and screaming to do this. This is done voluntary. They would like to get to 100%. I think the issue that Tim was answering is, should it be co-located with renewable energy? Now, data centre operators don't think they are good candidates to be operating energy plants. We saw a bit of that in the US. That's not what we want to do. We're building on the urban fringe. That doesn't make a lot of sense. So being able to invest in power purchase agreements with people that are building renewable energy projects, giving them long-term certainty, so signing 15, 20-year agreements to purchase that energy. We think that's the best way to do it. The other point about sort of this co-location thing is as data centers operate 24/7, so that you need firming. So thinking you can just plug into the solar array in Dubbo and run a data center without firming, that's not going to operate.
Yes, that's an interesting point, I guess, because some of the reports that have been produced for the CEFC, for Bringa, and a couple of other researchers here have suggested that consumers in some states could see a 25, I think New South Wales was 26% increase in prices, potentially, based on the growth of centres over the next 10 years. And a good portion of that growth in cost would be because of gas peaking, potentially, to keep, as you say, that 24/7 service available. I know, Tim, you've mentioned that you're interested to see what data centres might be able to offer in terms of load flexibility and better utilisation of the network. Do you think that is something both that is possible and is part of good conversations you're having?
I think it's important when we talk about pricing is also to remember that the bill is split up into different pieces.
Yes.
There's obviously the wholesale price, which is what a lot of people focus on, but actually the network price for the average customer is somewhere between a quarter and a third of the bill, depending on exactly how you do the calculation. And it's important to remember that is actually a fixed cost divided by the number of kilowatt hours in the system. So actually, if you can get electrification up, and data centers is a great example of really driving electrification, you're dividing what's basically a fixed cost or a cost that should be going up far slower than the actual electrification load by a bigger number of electrons. And actually, from a network cost point of view, that's really helpful. So that's one plus point I would bring out. Secondly, I'd also say that a lot of people in this room will have heard of minimum system load issues that AMO talk about in the middle of the day, when there's so much solar sloshing around that actually it's like trying to ride a bicycle very, very slowly. You can fall off quite easily. And so they're looking for ways to soak that up, and actually having some guaranteed large loads on the system that can soak up excess solar power is really, really helpful. So it's like all things, there's good and bad. And so from a network operation point of view, data centers have some really, really positive things to bring. And there are some other challenges, but like any new burgeoning industry that's learning, and the networks are learning how to work with them, and we're learning how to work with us. Things like flexibility, especially in the evening peak, is being developed, and we'll get there. We've seen that with lots of other big industries like aluminium smelting, things like that.
Lewis?
One thing I wanted to qualify with a 26 gigawatt. You represent a 26 gigawatt solar generator, but you don't behave like a central generator. The reality is that distributed compute will be a thing. It's far more efficient than centralized compute for inference building. We done the applied research, that's not a disputable point. We do see that data centers will evolve into a more fragmented paradigm, not these hyperscalers. The reason why we have these hyperscalers is because it's a very inefficient LLM boom that we're going through. Now, in my view, the compute portfolio of data centers in 20 years is going to be some fundamentally different of how they get contracted today. One of the responsibilities we have to do is to not think of 26 gigawatts that has to be a hyperscaler in the grid, but how much of that can be distributed. And we are going to go back to a point of a smaller, more specific compute capabilities that obey an industry, or maybe in community-based compute that you can do within your homes, right? That's obviously what the research is saying. There is no contracts that pertain to that right now.
Okay, that's awful. Now, I know, Belinda, you're going to have something to say for 30 seconds, and then we're going to change track a bit.
I can't, because this is an important point. The hyperscale large language model data centers that you're probably reading a lot about in the US that Lewis is talking about, we don't have those here. And because of our copyright laws, we're probably not going to have those here. So we're already at that point of much smaller. I mean, when we're talking about a large data center in Australia, it's like a 500 megawatt, and they haven't been built yet. That's the sort of potential. It's not these gigawatt, 2 gigawatt centres that we're seeing in the US, and Australia is just very different from the US. So the US, 5,400 data centres, 54 gigawatts of capacity. Australia, around 250 data centres, 1.4 gigawatts. So just vastly different.
Yeah, indeed. And I guess the only thing that we can be sure about is anything we say today is not going to happen. There's going to be a new and different future that none of us can probably predict, although many of you would probably be better situated to predict it than any. One one observation that I guess I would make, and that's reflected by a number of the questions here, is the degree to which there's a certain inevitability. I mean, Lewis, when you were talking, you said, this is what your home is going to look like. This is the world that you're going to occupy. And it's interesting, a number of the questions talk about tech bros.
Yeah, my Gen Xers are reacting.
We live in this sort of adolescent tech bro kind of cultural space in a way. And so I'm interested in the great inevitability of it all. Is there consideration being given, as you say, to alternative views, to decentralising structures, as you mentioned, but also, is there a 10-year-old in a garage somewhere that's going to come up with something altogether different? Again, is that the only reliable thing? Are we staring into an AI future that is incontrovertible, unshiftable? Is this something we should embrace, or should people be?
I wouldn't use unshiftable, but there is some very easy things to predict. Let me explain. Concrete example. If you are above 45, your first dates that you did in school or university were a high-risk proposition. You were in a bar. Well, you're in Australia, very likely probably you were in a bar or in university. You had to meet the bloke. You had to go talk to him, and you took some risks. Go 10 years from now. They're going to meet in the hyperspace. They're going to have a few meetings in the metaverse before, most likely, the woman decides that, I trust you enough to see you in person. Wouldn't you want that for your grandchildren? Think about it. And it is not your choice. That's the part that I'm telling you. Talk to a gen setter. They do not want to interact with the real world without some protection. Data is protection. Imagine you go on a taxi in Indonesia now, for those of you that have been to Bali. How certain are you that that taxi is not going to run out of gas where you're going? You don't know, but we're Gen Xers, right? So we live in the area of risk. We can take that taxi, no problem. But my nephew, who's 5, he's going to want to know probability of getting there, how well maintained the car is, start rating for the driver before I get on. They are privileged with data and evidence for decisions that matter to them in their everyday. You're not going to take that away. If you think about your bathroom, what are you going to go back? Spray and pray to have a medicine, see if it takes your infection away? No. They're going to want constant monitoring every day that they're progressing the way they're doing, and change their doctor, change their medicine when something's not working. So this is why I don't think it's an option of design, is the aspect of how much this technology can empower humans that is inevitable.
So perhaps the last question, and then we'll wrap up, which rolls together a few of the questions that some people in the audience have made, relates to what we might call a bit of a Marxist phrase, central planning. Now, a lot of your recommendations where there's this sort of greater sort of hypostatic union between data and communications, both in political portfolio terms and in planning, to extend the ISP as a foundational document for us into consideration of a national AI strategy, to maybe locate data centers physically and in terms of cable, but also in pricing terms more proximately to one another. All of these things presuppose a level of planning and consultation and sort of agreement between parties. I'm sort of interested in 10 or 20 words from each of you. How confident are you that those conversations are happening, that we are converging in terms of regulators, government policy, and so on? And how confident are you that that will continue to happen, or that we will just end up with an organic outcome that may be suboptimal? So, Belinda.
So yes, data centers and energy are now inextricably linked. They are one system. And if we want to be part of the AI future, and just the alternative is we don't have the infrastructure here and we just import other people's products with other people's values and other people's regulatory, and we're held as a client state nation. So that's the alternative, or we embrace this and we think about how we actually redesign how we interact with the energy system. That is already happening traditionally, going through distributors. We now need to look at how you go direct to the grid. I mean, I think one of the challenges is the energy market is incredibly complicated and complex in the number of players in here, but we are having those conversations. And then also state and federal government makes it difficult, but we are having those conversations, and I with the government recognising this is an opportunity they want to grab, then I believe that we will have those conversations.
Helpful, thank you. So 20 seconds each.
20 seconds. So energy industry and data industry are critical infrastructure. That has to be accepted and planned accordingly. The data industry and energy industry have the responsibility to deliver energy and intelligence reliably, cheaply, safely, and sustainably. When we agree on that, they can learn from the energy industry how we keep critical infrastructure and the social license we've earned over the last 100 and some years, but we need to learn from them how to innovate. Because for us to be in a good position in 20 years, all this requires innovation.
Helpful, thank you, Lewis. Tim.
I think the only thing I'd add to the other two is that we need to just get quicker. Yes, the right conversations are being had, the right people are approximately in the right rooms, but we need to get a lot quicker. Having a 5-year regulatory cycle, so I need to decide now what I think is going to get built in 2034, is just ludicrous given how fast things have moved. If you look back 5-6 years and think how much the world's moved on since then, we've got to find a way of unlocking the very slow pace of the way the grid evolves, and having those conversations with the data centers, because we've got to work together to get to the end point, and we can't be stuck in a 5-year regulatory cycle. So ways that can unlock that must be found.
Super, thank you. Well, you heard it here first, all sorted out. We knew it would only take half a morning to get this done. Thank you very much. Please extend your thanks to Belinda, Lewis.